100 years ago, a deceptively simple formula revealed a hidden unity buried deep in the fabric of the universe. It tells of a fantastic connection between energy, matter, and light. Its author was a youthful Albert Einstein. It's the most famous equation in the world. E equals mc squared. But while we've all heard of Einstein's big idea, very few of us know what it means. In fact, E equals mc squared is so remarkable that even Einstein wasn't sure if it was really true.
Albert, darling, you're later than I expected. We've only got sausage and cheese tonight. What is it?
We need to talk.
Has something happened?
Oh, no, nothing. Sorry, no. I spent most of the day staring out the window at work, looking at trains. And I started to think about an object and how much energy it had. Can I explain it to you?
Of course you can. But first, dinner, food and talk.
I think the gods are laughing at me.
The gods were not laughing at Einstein. He'd united in one stunning insight, the work of many who had come before him. All of nature had been classified into two great domains. There was energy, the forces that animated objects, and there was mass, the physical stuff that made up those objects. The whole of 19th century science rested on these two mighty pillars. The laws that governed one did not apply to the other. But young, newly enrolled physics student Albert Einstein didn't like laws.
Good grief, Einstein. What happened to you?
It is more than a little ironic, having been reprimanded yesterday by that idiot Professor Pernay for poor attendance, that I should in fact attend a practical lesson, which was as long as it was boring and utterly pointless, by the way, only to be the victim of an explosion of my own apparatus.
So it was your own fault then?
Thank you. And how are you today, Fraulein Marriage?
Extremely well, Herr Einstein. All the better for seeing you have escaped the physics laboratory with your life.
Well, in order not to alarm you any further, I pledge to forever continue my studies here at the Café Bahnhof, reading only the great masters of theoretical physics and eschewing the babbling nonsense of the polytechnicians.
It's about all you ever do.
It's getting a little stuffy in here, Fraulein Marriage. Would you care to take a walk with me? There's something I'd like to discuss with you.
Why, Herr Einstein? Of course. Perhaps you'd like me to tell you what you have missed in lectures this week.
Einstein wasn't exactly a model student. He excelled in certain subjects, especially physics and math, but he wasn't very diligent in a lot of his other classes. He was undoubtedly very questioning, which seems to have annoyed most of his professors throughout his life. He would pursue his fascinations with just incredible determination.
We know from his letters that Einstein, even from the age of 16, was literally obsessed with the nature of light. Everyone he could speak to, his friends, his colleagues, even his then girlfriend, Mileva Merrick, who would become his wife, everyone he badgered with the question, what is light?
What would I see if I rode on a beam of light?
What? A beam of light? By what method do you propose to ride on this beam of light?
The method is not important. Let us just imagine we two are young, radical,
bohemian experimenters, hand in hand on a journey to the outer reaches of the universe, and we are riding on the front of a wave of light.
I really don't know what you are suggesting, Herr Einstein. Do you wish to hold my hand or ridicule me?
Ridicule you? No, never. I merely want you to help me to understand. What would we see, do you think, if we were together and we sped up and up until we caught up to the front of a beam of light?
It was Einstein's relentless pursuit of light which would bring about a revolution in science. With light, he would reinvent the universe and find a hidden pathway that would unite energy and mass. Light moves incredibly fast, 670 million miles per hour. That's why scientists use the term C. It stands for celeritas, Latin for swiftness. Long before the 19th century, scientists had computed the speed of light, but no one knew what light actually was. Back in England, a man we've already met was willing to make an educated guess. After Sir Humphrey Davy's death, Michael Faraday became Professor Faraday, one of the most important experimenters in the world. The scientific establishment still found it hard to accept that electricity and magnetism were just two aspects of the same phenomenon, which Faraday called electromagnetism. But now, he has an even more outrageous proposal for his audience.
Invisible lines that can emanate from electricity in a wire, from a magnet, or even from the sun. For it is my contention that light itself is just one form of these vibrating lines of electromagnetism.
For 15 years, Faraday struggled to convince the skeptics that light was an electromagnetic wave, but he lacked the advanced mathematics to back up his idea. Eventually, someone came to his rescue. Professor James Clerk Maxwell believed in Faraday's far-sighted vision, and he had the mathematical skill to prove it. Maxwell and the aging Faraday became close friends.
James, forgive me. A word of advice. Don't get old.
Michael, how are you?
I'm fine. Memory isn't too good. But...
Well, I thought you might like to see what I've just published.
Oh, yes. Yes. Splendid.
So your results show that when electricity flows along a wire, what it actually does is create a little bit of magnetism. And as that magnetic charge moves, it creates a little piece of electricity.
Electricity.
Electricity and magnetism are interwoven, like a never-ending braid. So it is always pulsing forward.
It's wonderful.
Michael, there's something very crucial in the maths. This electricity producing magnetism and magnetism producing electricity, it can only ever happen at a very particular speed. The equations are very clear about it. They come up with just one number.
670 million miles per hour.
I'm not sure.
It was the speed of light. That is the speed of light. That means you were right all along. Light is an electromagnetic wave.
Maxwell had proven Faraday right. Electricity and magnetism are just two aspects of a deeper unity. A force now called electromagnetism, which travels at 670 million miles per hour. In its visible form, it is nothing other than light itself. And nothing fascinated the young Einstein more than light.
We have lectures in half an hour.
Oh, let me think. Professor Weber and his life-draining monologue? Or you, Mozart, and James Clerk Maxwell?
We can't. We'll get a warning.
Our project is too precious to waste time listening to those dullards. Come with me. We'll read Maxwell and think about the electromagnetic theory of light.
Oh, why, my dear little Johnny, how you enchant a lady.
Maxwell's equations contained an incredible prediction. They said you could never catch up to a beam of light. Even if you were traveling at 670 million miles an hour, you would still see light squiggle away from you at 670 million miles an hour.
Do you see how she stares at that wave?
Yes?
You see how for her it is static?
Yes?
She and the wave are traveling at the same speed. We see the wave moving through the water, but relative to her, it just sits there. So is light like that?
Common sense would say that if you caught up to a light beam, there would be a wave of light just sitting there. Maybe it would be shimmering, a bit of electricity and a bit of magnetism.
So, if she was traveling alongside the light wave, it wouldn't be moving. It would be static. But Maxwell says you can't have static light.
Maybe Maxwell is wrong. Maybe if you catch up to light, it is static, Albert, like a wave next to a boat.
Imagine if I was sitting still and holding a mirror to my face. And the light travels from my face to the mirror, and I see my face.
Yes?
However, if I and the mirror were traveling at the speed of light...
You're going at the same speed as the light leaving your face.
Exactly.
The light never reaches the mirror.
So would I be invisible?
That doesn't make sense.
Young Einstein was starting to realize that light was unlike any other kind of wave. Einstein was about to enter a surreal universe where energy, mass, and the speed of light intermingled in a way no one had ever suspected. Einstein pursued light right through university and beyond. Unfortunately, he'd upset so many professors that no one would write him a reference. He accepted a low-paying job in the Swiss patent office. He and Mileva married and had a child. The young family struggled, but none of it seems to bother Albert.
Einstein, I see you are busy, as usual. Look, Einstein. You have shown some quite good achievements, but listen, about your promotion. I really think it would be better to wait until you have become more fully familiar with mechanical engineering. I'm sorry. Perhaps next time.
wanted to hire a maid so I can get back and finish my degree. Now I will never pass my dissertation.
Oh, come, my pretty little duck. All will be fine. You'll see.
How will it be fine, Albert? Do I have to just wait another year until you are promoted? Come on, come on, my boy. Oh.
All will be fine. All will be fine. You'll see.
There really is a very charming but kind of a self-centered streak to Einstein. He focuses only on his particular obsessions. If the rest of the world fits in around him, that's fine. If they can't, it doesn't bother him.
And he's going to come and tell us. Wow. Albert. A pretty neck and your head spins.
Okay, so we must behold and comprehend the mysterious.
Well, that kind of mysterious is going to get you into trouble.
I'll tell you what is truly mysterious. The secret of a long and happy marriage.
The mathematics are fine, if a little unconventional, but this only works for big systems. It'll fall down when you apply it to small systems.
I disagree.
Oh, no. Here we go. Another grand theory by Herr Albert Einstein, a patent clerk, third class.
What would happen if one applied those formulae to electromagnetic radiation?
Albert, you can't just take one bit of physics and apply it without proper regard to a completely different area.
Why not?
Albert, I know you like the grand linkages, the big theories, but wouldn't things be better all round if you just got going in some small area? Got a university post, get a decent wage, for God's sake. At least Mileva could study again. Then she'd be happy, and you'd be happy.
Ah, the vulgar struggle for survival. Food and sex. Spoken like a true bourgeois. Bessel, I want to know how God created this world. I'm not interested in this or that phenomenon, in the spectrum of this or that element. I want to know his thoughts. The rest? The details.
Yes, but you can't feed your children on his thoughts, Bertie.
So it turns out Einstein was going for a walk with his very close friend, Michel Besso. They'd studied physics together and talked about physics and philosophy for years and years. They were very close. They had cornered the question of light from every possible angle.
See, this clock's over here.
As Einstein and Besso were ruminating on how much time it would take light to reach them from clocks at different distances, Einstein had a monumental insight.
Thank you. Thank you. I have completely solved the problem.
Albert!
What Einstein did was completely turn the problem on its head. Other scientists had found it impossible to accept Maxwell's idea that light would always move away from you at 670 million miles an hour, even if you too were traveling really fast. But Einstein just accepted that as a fact. Light's speed never, ever changes. Then what he did was bend everything we know about the universe to fit light's fixed speed. What he discovered was that to do that, you have to slow down time.
His extraordinary insight is that time, as you approach the speed of light, time itself will slow down. It's a monumental shift in how we see the world.
The very instant when Einstein had this brilliant insight that time could slow down, well, the floodgates began to open. You see, before then, people had assumed that time was like a wristwatch on God's hand, that it beat at a steady rate throughout the universe, no matter where you were. Einstein said no, that the tick-tick-tick of this wristwatch was actually the click-click-click of electricity, turning into magnetism, turning into electricity. In other words, the steady pace of light itself.
In 1905 was a miraculous year for Einstein and for physics. He had an unbelievable outpouring of creativity. It starts with his publication of a paper on how to work out the true size of atoms. 2 months later is the publication of his paper on the nature of light. That's what will earn him the Nobel Prize. The third paper, only a month later, is on how molecules move when heated, and that finally ends the debate on whether atoms really exist. The fourth paper is published at the end of this half-year period. In it, Einstein sets out his theory of light, time, and space. It was this theory of special relativity. That changed the way we see the world.
In Einstein's new world, the one true constant was not time or even space, but light. But Einstein's miracle year was not over. In one last great 1905 paper, he would propose an even deeper unity. As he computed all the implications of his new theory, he noticed another strange connection. This one between energy, mass, and light.
Einstein realizes that the speed of light is kind of like a cosmic speed limit. Nothing can go faster. So imagine we have a train charging along, and let's say it's getting up to the speed of light, and we're stuffing more and more energy in, trying to get it to go faster and faster. But it's still bumping up against the speed of light. So all this energy, where does it go? It has to go somewhere. Amazingly, it goes into the object's mass. From our point of view, the train actually gets heavier. The energy becomes mass. It's an incredible idea. Even Einstein is amazed by it.
Look, I think I have found a connection between energy and mass, if I am right. Then energy and mass are not absolute. They are not distinct. They can be converted into one another. Energy can become mass, and mass can become energy. And not just energy equaling mass. Energy equals mass times the square of the speed of light.
Would you like me to check your mathematics?
Einstein sent his fifth great 1905 paper for publication. In 3 pages, he simply stated that energy and mass were connected by the square of the speed of light. E equals mc squared. With 4 familiar notes in the scale of nature, this patent officer had composed a totally fresh melody, the culmination of his 10-year journey into light.
Here we are for thousands of years thinking that over here is a world of objects, of matter, and over there is an entirely separate world of movement, of forces, of energy. And Einstein says, no, they're not separate. Energy can become mass. And crucially, mass can also become energy. There's a deep unity between energy, matter, and light.
E equals mc squared. That equation shows that every piece of matter in our universe has stored within it a fantastic amount of energy. The speed of light, for example, is about 300 million meters per second. You multiply that by itself, and you get 90 quadrillion. So in other words, what is matter? In some sense, matter is nothing but the condensation of vast amounts of energy. So in other words, if you could somehow unlock all the energy stored within my pen, that would erupt with a force comparable to an atomic bomb.
After Einstein's fifth great 1905 paper, physicists no longer spoke of mass or energy. They're now the same thing to us.
Probably the most miraculous year in science ends in silence. The articles are published to resounding nothing.
I think the gods are laughing at me.
Then slowly, it starts. A letter here, a letter there. For 4 years, Einstein answered each inquiry dutifully, trying to explain his difficult, complex ideas to a confused physics community.
I love the idea that life just went on as normal. Here are these universe-changing papers circling around, and the world is struggling to come to terms with them.
Einstein had a fan club of just one. Luckily, it happened to be the most important living physicist.
Einstein. Einstein. Max Planck has sent someone to see you.
Max Planck?
Yes, he has sent his assistant. He's here to see you.
Max Planck encourages the world's most eminent physicists to take Einstein seriously. After 4 years of waiting, he is appointed professor of physics at Zurich University. From there, his career is meteoric. He is made professor of physics in Berlin, achieves world renown, and becomes a household name. He is the undisputed father of modern physics. E equals mc squared became the holy grail of science. It held out the promise of vast reserves of energy locked deep inside the atom. Einstein suspected that it would take 100 years of research to unlock it, but he hadn't banked on the Second World War in Hitler's Germany.
At this time, not a lot was known about the atom. At first, people thought it was like a miniature solar system. There was a solid nucleus at the center, and electrons would spin around it, sort of like planets around our sun. A little later, some researchers proposed that the nucleus itself wasn't a solid chunk, but was made up of separate particles of protons and neutrons. But then, in what are called radioactive metals, things like radium and uranium, the nucleus itself seemed to be unstable, leaking out energy and particles. Perhaps this was an example of E equals mc squared, the mass of a nucleus turning into energy.
In 1942, an intense effort to build an atom bomb was begun. All over America, secret installations sprang up under the code name the Manhattan Project. A nuclear bomb was never used on Germany, but the atomic bombs dropped on Hiroshima and Nagasaki demonstrated the terrible destructive power of E equals mc squared. Vast amounts of energy in the form of electromagnetic radiation were released from a few pounds of uranium and plutonium. While the pure inquisitiveness of the world's most gifted scientists ironically had brought humanity a weapon of mass destruction, the equation's life has a parallel story of creation and beauty. Today, young physicists carry on Einstein's quest. Ever since its birth, E equals mc squared has been used to delve into the depths of time, to answer the biggest question of all: where did we come from? At particle accelerators, researchers propel atomic particles to the speed of light and smash them together, creating conditions like those in the Big Bang.
E equals mc squared actually tells us how the Big Bang itself happened. In the first moments of creation, the universe was this immensely dense, immensely concentrated eruption of energy. As it rushed apart and expanded, huge amounts of energy, or E, were converted into mass, or M. Pure energy became matter. It became the particles and atoms, and it eventually formed the first stars.
Our sun is a huge furnace floating in space, and it's powered by equals mc squared. Now, it turns out every second, 4 million tons of solid mass of the sun disappears. Comes out as energy, not just a little bit of energy. It's enough to light up our entire solar system, make the solar system glow with heat and light.
And not only do stars emit energy in accordance with E equals mc squared, the whole process actually creates life itself. Eventually, a massive star dies. The debris floats around, clusters together, gets pulled into the orbits of another star, and becomes a planet. We humans and the Earth we stand on are made of stardust. We are a direct product of E equals mc squared.